Greetings to every one of you. In this video, we are going to discuss about another very important and interesting concept from data structures. This is AVL trees. AVL is named after the discoverers Adelson, Welski, Landis. So these three people together, and they proposed this AVL tree structure. In order to know about AVL trees, let me start from binary tree. So the binary tree is a data structure in which we can have maximum 2 children. This is a binary tree, this is a binary tree, and this is a binary tree. So the maximum children are 2, no children, or single child. These are binary trees. In case of binary tree, if you perform searching operation or any other kind of operation which require the time complexity order of n. So n represent the number of nodes. In order to that is improve the speed and reduce this time, the next concept was introduced called binary search tree. So in binary search tree, the values of the nodes will be sorted. Like this is the left node and right node. If it is 10 and this must be that is lesser than the root node, and right hand side value must be that is greater than the root node. So keeping the lesser value on the left hand side and greater value on right hand side, that is the concept of binary search tree. So in case of binary search tree, we will have the values like this. So this is a greater value. So similarly, this is lesser value, greater value. This is a binary search tree. You can see all the data are in the sorted order. The left hand side value are lesser than the root value, and right hand side value are greater than the root value. So if you take the time complexity of the binary search tree, it is log of n. So by means of sorting, we are able to that is improve the time complexity. Again, this is a problem in case of the binary search tree. Let us consider if you have the data in ascending order or in descending order, that will leads to left or right skewed trees. For example, you have data like increasing order 55, 66. So this is 11, and the next value is greater than the root node, so automatically it goes to right hand side. So this is also the greater one, 44, 55, 66. So this being the case, if you take this order, it is nothing but order of n. The time complexity, it is order of n, because you have all the values in the ascending order. It is what is called right skewed trees. Right skewed tree. Similarly, let us consider if you have the values in the descending order 66, 55, 44, 33, 22, 11. So this being the case, you will keep the values, the lesser values on the left hand side. So automatically we will get the left skewed tree. So for this case also you will get the order will be that is the time complexity will be that is order of n. So this particular disadvantage of the binary search tree can be removed using a technique that is what is called rotation. So that will result in the evolution of AVL trees. Okay, how to that is balance these skewed trees? See, let us consider example of a binary search tree. We have this a binary search tree in which you have the left hand side you have 2 nodes and right hand side you have 2 nodes. We have to that is find out the balance, whether this tree is balanced or not. So the balancing can be that is find out by means of calculating a value called balance factor. This balance factor is nothing but calculating the height of left subtree minus height of right subtree. So this will give you the value of the balance factor. Always this balance factor must be that is equal to -1, 0 or +1. If it is more than this value, 2 or -2 or lesser than this value, then the tree which is unbalanced. If it is unbalanced, you have to perform an operation called rotation. So by means of doing this rotation, we can get the balanced binary search tree, that is nothing but the AVL tree. So AVL trees are balanced binary search trees. Okay, so in this case we can just find out the balance factor. So for this one, the left subtree, no, there is no left subtree. Similarly, there is no right subtree. 0 minus 0, that is nothing but 0. What about this one? This one you have left hand side, this is one node. Right hand side, there is nothing. So 1 minus 0, which is equal to, there is 1. Similarly, this one, if you take this one, on left hand side you have that is 1 plus 2, 2 nodes. On right hand side that is 1, this is 1, this is 1. So 2, which is equal to 0. Similarly, this one, it is 0 minus 0, 0. So what about this one? This is 0 minus 1. So left hand side, that is left hand side you have there is no node here. On right hand side there is one node, so 0 minus 1. So this is minus 1. Actually this is a balanced tree, because the values what actually we got is 0, 1, minus 1. So within this given range. Okay, if it exceeds this value or goes less than this value, then that is not the balanced tree. That require some operation called rotation. So let us discuss some of the important cases in the binary search tree. Let us consider the data 6, 7, 8. This is case 1. This is the root node, and the next value is greater than this, so it will come to the right hand side. Next, the 8, that is also there is greater value, goes to that is the right hand side. It results in the right skewed tree. Okay, so what is required? See, if you calculate the balance factor here, it is there is no left and no right. This is 0 minus 0. So here there is no left and no right. This is, I mean, there is one right, 0 minus 1. And here, if you take this area, this is 0, but here you have that is 2 nodes. So 0 minus 2. So this value is 2 now. So what you have to do? You have to perform a rotation operation to make this tree balanced. Okay. So actually the problem occurred here. So what you have to do, you have to keep this your finger like this and perform rotation in the anti-clockwise. Okay, so this is the direction you have to, that is, rotate. So as a result, what will happen, this 7 will be here, and 6 will go here, and the 8 will come here. Okay, so what actually I have performed, we performed the rotation of this type, we got this value. So it is right, the case is right, both are right. The result, we got this balanced binary search tree. Similarly, the case 2, the next data is 8, 7, 6. This is the value, this is 8, and 7 will come here, and 6 will comes here. It results in there are 2 left operation, so left data, so it results in left skewed tree. Okay, left skewed tree. So what you have to do now, you have to perform a rotation. So if you calculate the balance, this is 0 minus 0, this is 1 minus 0, and here this is 2 minus 0. Left hand side we have 2 edges, and right hand side there is nothing, so 2 minus 0. So you have to keep your finger like this. Okay, perform rotation like this, so this kind of rotation. Okay, so as a result you will get the value, that is 8, and if you perform rotation, this 7 will come here, 8 will go here, and 6 will come here. Okay, so 7 is the center, the 6, that is a lesser value on the left hand side, and 8 is a greater value on right hand side. So this results in, okay, this now it is balanced. Similarly, case 3. So this is left. Case 3, I take the data, that is 10, 12, 11. So start from here, that is a 10, and 12 is a greater value, but again next value is 11, that is a smaller value. So this is right, left, the case is right, left. So this being the case, what you have to do, you have to, that is, perform the rotation like like this. You have to perform the rotation like this. So as a result, what will happen, as a result, the 11 will go up and 12 will come down. Okay, so this is 10, 11, and 12. Okay, right skew tree. So we know that how to, that is, perform how to convert this RR case into the balanced one. So what you have to do, you have to, that is, keep your the finger like this, perform the rotation like this. So 11 will come here, 10 goes here, and the 12 will come here. It is balanced. So what you have to do, you have to perform rotation like this. So what will happen, this value will go like this. Okay, similarly, case 4, it is 10, 8, 9. The value is 10, 8, 9. Take the value, this is 10, 8 is lesser than the value, then 9 will go here. So this is left and this is right. Case is LR. Okay, so now what you have to do, you have to, that is, make this as a left skewed tree. So left skewed tree, what you have to do, you have to perform this operation like this. Okay, so what will happen, this 9 will go here, 8 will come down, 10, 9, and 8. Okay, so now we got the left skewed tree. You know that how to convert the left skewed tree into its corresponding balanced tree. So what you have to do, here you perform the, what's that, right hand side rotation. the same thing, you have to perform the rotation. So what will happen? You have to perform the rotation like this. So as a result, what will happen? The 9 will be here, and 8 will be here, 10 will be here. So these are the 4 different cases of converting unbalanced binary search tree into a balanced one. So the balanced binary search tree is called AVL trees. Okay. In the next video, we'll discuss how to create AVL trees. Thank you.